Okay, so I guess we're good to go. Yes? Hey, good morning, everyone, and welcome to our Sippin' Ground Coffee. This is a summer series of web training sessions. Each one of these, there's 2 tracks, and there's 3 sessions to each track. This is actually track 1, session A. If you complete all 3 sessions of a given track, I think there may be something in the line of a award or reward for you at the end of this summer series. So anyway, my name's Dan Painter. I don't know if I told you that to begin with, but we've got a myriad of topics that are going to go on today. We're going to be talking about testing submersible motors with meters and Meggers. So if you're on your way to the job site or you're on your way to the office or wherever you may be tuned in, grab that coffee and let's go ahead and get started with this first topic here. All right, just as we expected, this is the very first run, and be patient with us because I got a whole staff here behind us, and I'm sure one of them is going to make this clicker work again. My presenter's not moving any slides anymore. Okay, so just bear with us just for a second. Nope, it was working just a second ago. There we go. All right. Let's go ahead and try to get this thing off out of the starting blocks. We're going to be talking about meters and Meggers today. We're going to start off talking about multimeters. Some people call these ohm meters. They've been around for a long, long time. And for anybody that may be new, if this is something that this is going to be new to you or you're new to the industry, these first few slides or first few comments are going to be geared for you as we cover just some of the fundamentals with these meters. First of all, they measure, thank you very much there. Appreciate that ground coffee. So multimeters or ohm meters, they're going to measure what's called resistance, and when they do, they're going to express that resistance in a term referred to as ohms. So that said, if there is absolutely no resistance when we're testing a motor, then that would mean there's 0 ohms are going to be displayed. Anytime 0 ohms is displayed, all right, and this is something you want to be sure you're aware of, that can be displayed one of 2 ways, and it's going to be dependent really upon the meter that you're using. So just understand which way your meter is going to display those ohms. One way, and probably the most popular way, is simply an OL. I believe that stands for open lead, but that's a display that's oftentimes used on a lot of meters to display infinity. The other method of displaying it is just simply a 1. All right, so again, make sure you know how your meter's displaying infinity. Also, be aware there's a couple of type of meters out there. All right, the one on the left, that analog, I cut my teeth on that many, many years ago. That was an old analog meter. They're still used today and very, very accurate. Just be aware that if you are using an analog meter, there's going to be a dial at the bottom to take your measurements. And you want to set that dial before you take your measurements. I've always set it on the highest setting, and then I'll work my way back from that point to get a more accurate reading. There's also a dial in the center that's going to have to zero out that meter. So you want to make sure every time you do this and before you use this that you set that range down at the bottom and you dial in that, zero in that needle on that analog meter. Now the other one is digital, and very popular. I mean, most of the people in this industry today grew up in the generation of digital, so one of the nice things about them, they have auto ranging features, so you don't have to set any scale. They even you don't need to zero them out either. So again, just be aware there are 2 meters. I don't care which one you use because what we're going to be talking about doesn't matter which meter you use. And again, irrespective of the meter, there's a lot of things that you can determine with a multimeter as far as a submersible motor goes. You can determine whether a motor has a short, whether it has open windings. Perhaps it's got mixed leads. You can actually do lead identification with a multimeter. And of course, the bottom one there, we can always determine whether a motor is grounded or not. So again, these meters are going to show these values in resistance, and I think understanding those values is what we're really going to aim on today. So you know when you put your meter on a motor, what it's telling you, so that you can determine whether, again, it's a short or a ground or an open winding or what have it. A CYA comment here. Make sure you cut the power off to the motor. We don't want any power going to that motor when you're putting a multimeter on it, because it will test for resistance with no power applied. And then, of course, the last thing you're going to want to do is make sure you've got functionality, all right? So the way you determine that is cross your probes, your red and black probes, cross those. And again, irrespective of the meter, when you do cross those two probes, you ought to get a infinity display on your meter. So that's just to make sure that everything's functional, so that you get good results and good readings when we go into the motors. Yeah, speaking of the motors, you know, there's two types of submersible motors out there today. Most of you are all aware of that, I'm sure. The first type is what's referred to as a two-wire motor. You know, very, very popular back, I would say, you know, east of the Mississippi, two-wire submersible pump motors become very, very popular there. So with the two-wire motor, you're going to have two black leads. We'll just call those A and B. And then you're going to have a green ground. And then, of course, then there's the three-wire motor, all right? And that's, the three-wire motor is really what submersible motors started off day one. They were all three-wire motors back in the day, so this is just an opinion, but in my travels, I have found that as you go west of the Mississippi, you find more three-wire motors are installed versus east of the Mississippi, where it tends to be more two-wire motors. So on a three-wire motor, you're going to have a red wire, which is your start winding. Your black is the run, your yellow is the common, and then you're going to have a green ground. All right. So again, whether we're talking about a Flint and Walling motor or anybody else's for that matter, these color-coded cables are going to apply to every, you know, motor manufacturer. All right. So just understand that there are two black leads and a green ground on a two-wire motor, and there's a red, yellow, black, and a green ground on a three-wire motor. All right, so let's go into looking at how we're going to test these motors. All right, so I'm going to throw up here, we're going to look at these first four. It's a short, open windings, mixed leads, and lead identification. And the reason I want to kind of bunch these together is for this reason. All right, here we go. We got these four that we're going to do, and the purpose behind I want to group them together is because the way we measure is always going to be each lead to lead for every one of those. And so the green ground wire is not in the picture at this moment in time. We're only going to be going for that lead to lead, all right? So when you do that and you put your probes on these lead wires, you're going to get resistance of some type, all right? You're going to get some type of a display in your multimeter. It's going to display it in ohms. And I guess we need to understand, is this reading good? Is it bad? How do we know? Well, everybody that manufactures motors, including Flint and Walling, we put out what we call a motor application guide, all right? Franklin puts out an AIM manual. It's been around for years, very well respected. And every other motor manufacturer also puts out publications that will give us the answers to what these resistance values should be. So when you open these books up, you're going to come to a chart in the middle of this publication somewhere, all right? So let's just look at how this chart's used. If you look over on the far left-hand column, there's where we're going to identify whether it's a two-wire motor or a three-wire motor, right? So pretty simple stuff up to this point. That next column in, that's going to be the horsepower, all right? So again, pretty simple things. So you've got your horsepower and you've got your motor type. If you scroll way over, so about 3/4 of the way over that chart, you're going to come to a column that is labeled winding resistance, and therein lies your published values or your resistance values for each of those types and horsepower of motors, all right? So for an example, if we were looking at a two-wire motor and we need to pick a horsepower, right? Let's just go 1.5 horses. All right, so the way we use this chart, the way we understand how these values are going to come into play is we're going to scroll over to that winding resistance column, and in there is we're going to intersect in a box. And in that box, we're going to get what that ohm value should be. So in this case, on a 1.5 horse, 2-wire motor, you go lead to lead. You're going black to black. That's the only that's the only time you go lead to lead, black to black, and you're done. But when you do that on a 1.5 horse, 2-wire motor, you should be expecting those resistance values to come in at somewhere between 1.6 and 2.0 ohms. All right, so that's how we'll know whether we're getting resistance that's within that range or not. We got a comment, all right.
Hillary, she said, excellent insight, man. Appreciate how clearly you explain complex topics.
Oh, my goodness. Well, they're putting the pressure on me too early into this presentation, so we'll see if we can keep that going. But again, that would be the value when you come down with your probes on the 2 black cables or 2 black wires on a 2-wire motor. Let's look at this 3-wire motor. Let's just go ahead and keep the same horsepower, all right? So let's go with a 1.5 horse, 3-wire motor. Scroll across to the winding resistance column, and in the case of a 3-wire motor, you're actually going to have 2 published values, all right? You're going to have 2 of them. In our case, we call that first published value an M value, and that should be between 1.7 and 2.2 ohms. And then the A value is going to come in at 7.8 to 9.6 ohms. And if we're asking ourselves, you know, what in the world does M mean? What does A mean? Well, down at the bottom right-hand side of that chart, it'll tell you all that, all right? So if you're going to talk about the M value, that's going to be when you put the probes down on that yellow and black lead, you should expect 1.7 to 2.2 ohms. And the M value is the yellow to red, all right? So these are 2 published values for a 3-wire motor. And again, every pump manufacturer or every motor manufacturer, they're going to publish 2 values on their three-wire motors, right? 2 values on the 3-wire, 1 value on the 2-wire. So when we look at this then, about, you know, what we just talked about, and again, for you new guys, this is important stuff to know right here, all right? This is generic. This is going to apply to any motor that's out there. All right, so we talked about the yellow and the black, all right? That's that common and that's that run winding. We talked about that as having a value of 1.7 to 2.2 ohms, all right? So we'll call that the lowest value, If we go to that second published value, that's the yellow and the red, and when we put the probe on those 2, we should be coming in somewhere between that, again, that 7.8, 9.6 ohms. We're going to call that the intermediate value. Now there is another test that we can perform, and that's going to be on the start and run winding together, that red and black cable. Now there is no published value for that. Nobody publishes that value. And sometimes I've been asked, you know, well, you got 2 published values for the low and the intermediate, painter. What should that third one be? Well, you know, here's the answer, right? And some of you, I'm sure, know this answer, and basically it's pretty simple math. You take that lowest value, and you're going to add it to that intermediate value. And when you do, you're going to come up with what should be considered the highest value, all right? So if the lowest value is 2 ohms and the intermediate's 8, and you're coming in at, I'm not saying you have to come in right at 10, all right? But you need to come in where it makes sense. 10.1, 10.2 makes sense to me. 9.9, that makes sense to me. Close enough, all right? But that's how you're going to determine that highest value. Got another question coming in.
Yep. Tony asked, when checking for ohms on a motor, does the lead wire length make a difference?
When using a multimeter, the question, I don't know if everybody heard that question. You think they heard that, Renee, okay?
Yeah, when checking for ohms on a motor, does the lead wire length make a difference?
The answer is yes. There's the lead wire length. They're talking about the drop cable. And that's really going to come in play in the latter half of this presentation, actually a latter 25% when we start switching to Megohmmeters, all right? But multimeters are most of them, if you're going to test a motor with a multimeter, it's probably best to just test the motor right at the motor leads and not the entire drop cable. It can be done that way, but the resistance values are going to change on us, all right? So let's look at this now, all right? What we've talked about right up to this point is if you take the lowest value, that range, and you add that to the intermediate value, that should give you what we would consider to be the highest value. And again, that's going to be the case with anybody's 4-inch submersible pump motor. Knowing that, got a question again? Yes.
They asked, where does Flynn Walling publish these values? Can someone get their hands on it?
Yeah, so thank you very much. If you want to know where these values are published, go to what we call our motor application guide. If you go to our website and you click on the literature tab, scroll down to where it says Motor Application Guide, and there's 2 publications. One's an 8.5 by 11, and then there's this pocket guide like you can see here. But in these guides are going to be a chart, all right? And in that chart is what we're looking at on the screen there. That's where your published values are going to be shown for each type and each horsepower of motor. And those values are going to be specific to a Flint & Walling motor. If you want values specific to Franklin, Grundfos, Gould's, Penair, or anybody else, you got to go to their manuals and grab what their published values are. But when we talk about the lowest value plus the intermediate value equals the highest value, and if we know that the lowest value is that yellow and black, and the intermediate is the yellow and red, if we know that, if we retain that information, with that information, you can identify leads. You can identify leads that way. So let's look at what we've got coming up next here. We've got a 1.5 horse 3-wire motor. And so I'm going to come down on those yellow and black leads right here, right? So here we go. We're just going to do a little motor test here. And when you come down on that yellow and black, I should be between 1.7 and 2.2. You can see I'm coming in at 1.8. Hey, that's right within the range. I'm going to give that a green check mark. All right, now when we come down on the yellow and red, all right, we're going to drop down on the yellow and red. We should be coming in at 7.8 to 9.6. And as you can see, that's not the case, all right? So we've got a failure going on here with this particular motor, all right? That intermediate range failed. And I'll tell you this much. Anytime one of those top 2 fail, whether it's the yellow and black or the yellow and red, anytime one of those top 2 fail, go ahead and just terminate your testing at that point. You don't need to go any further, because I can assure you that anytime one of those 2 fail, that red and black, that start and run winding together, it'll always fail too. Always fail. So what we've got going on here, sorry about it. What we've got going on here is we've got some resistance values that are coming in lower, keyword, lower than published values, all right? Now, what's that mean? I'll tell you how I remember it. I remember it this way. If the values are coming in lower than the published values, and you look at these 2 stools here as an example, one's actually lower than the other. One could also be considered shorter than the other. So that's how I remember it. If the values are lower than published, then it's a short, all right? It's a short in that motor. If you want to shorten the grass, lower the motor. So lower always means short. So when we look at our little chart here, if you're coming in within range all the way across, hey, that's a motor, it's not shorted, all right? If you're coming in within range. However, if you come in below that, then you're going to indicate a short in that motor, all right? So that's pretty black and white there. So we're going to move on to the next one, all right? Let's move on to the next one. By the way, if you did want to take this one step further, I'm not sure you do, but if you did, you know that yellow and red failed up there at the top, and I told you that any time that one of those top 2 fail, that bottom one's always going to fail, so let's give it a red mark too. All right, so you look at those 2 categories, those 2, is there anything common between the 2? And I would venture to say yes, there is, and it happens to be that red wire. All right, so there's where your short's at. That yellow and black, when they were paired together, man, they work just fine. So it's that red wire that's going to have the short in it. All right, let's move on to the next one, okay? Let's do another test. Let's just stay with that same 1.5 horse, 3-wire motor. Let's just stay with that. But let's come down on that yellow and black. And again, we should come in 1.7 to 2.2. You just changed something on me there, friend. I am no longer advancing. I'm no longer advancing slides. Thank you.
That's my fault. Let me go grab Renee.
All right. So again, this is our. This is, can you hear me now type of thing? There you go. Thank you very much. All right, good. We're back. Again, this is our first shot at live streaming, so have a little patience with us. Just like a Little League baseball team, when it comes tournament time, we'll be a little better. So anyway, when you come down on the yellow and black, in this case, you can see I'm showing 8 ohms now. All right, that should come in at 1.7 to 2.2. So here's the difference between this test and the previous test. This time I'm coming in higher than the published value. All right, let's go ahead and check that yellow and red, see what that does. All right, 9.4. So that tells me we're within range, so it gets a good grade. But we still have a failure going on here. But the difference between this failure and the one that we had previous is that this time the published values are coming in higher. Or I'm sorry, the actual values, the resistance values, are coming in higher than the published values. Now, how do you remember that? You're going to find this probably a little corny, all right? I didn't do this for you, I did this for me, so I can remember it, all right? But how am I going to associate, what does it mean when values are coming in higher? All right, well, I thought about a window. And, you know, you can lift a window up. And when you do, you're lifting it up. You're raising it. You're lifting it up higher, right? So when you do that, what's the end result? Well, the window's open. So that's how I remember it. You know, raising the window, it's coming higher. Open winding, all right? So that's how I remember that. So if it's lower than published, it's a short. If it's higher than published, it's open winding. You also think of high, think of the open sky, right? The open sky. And again, when we talk about a failure in any of those top 2 categories, the third one's always going to fail. And so we can also look and see where that open winding's at by looking at those 2 categories and find the wire that's common. And in this case, it's the black cable. So you're going to have an open winding in the black wire, the black cable. And that's what that meter's telling us at this point. All right, so we're going to finish this one up within range. You're good to go. Windings are not open. But if you're coming in higher, that always indicates a open winding. All right, an open winding. All right, we talked about the mixed leads. We actually talked about the mixed leads. Well, maybe we didn't. We talked about lead identification. All right, let's talk about mixed leads. What happens when there's this thing called mixed leads? I'm going to tell you something. This is the rarest of the bunch. Probably not something that you're going to run into very often, but it happens. And so let's look at what happens when we have mixed leads. I'm coming down on that red and yellow, and I'm supposed to be coming in at a low value, right? Well, I'm not. I'm at 8. That's a high value. That's kind of like it was in the previous slide. So that failed. So now I'm going to switch over. I'm going to come down on that yellow and red one, see what I come in there. Whoop. Now, see, that's supposed to come in at 7.8 to 9.6, and look at that one. That's coming in lower than published values. That failed, all right? All right, so we had a failure in the first one. It was lower. The second failure we had, it was higher. This third failure, it's both, isn't it? It's coming in. It doesn't know which way to go. It's higher. It's lower. That's an indication of mixed leads, all right? That's an indication of what we would call mixed leads. So how in the world could that happen? I suppose it's possible, given the fact that we're all human. I suppose at the manufacturing level, right, while this motor was being manufactured, if someone didn't wire that lead socket properly inside that motor, all right, it didn't get wired properly inside the motor, so that when you bring the motor lead down on the outside of that lead socket, those wires aren't lined up. And that's what's, in other words, red's not on red, yellow's not on yellow, and so on and so forth. And anytime that happens, and you got those wires mixed up, you're going to get resistance values that are going to be both higher and lower than those published values. I don't know that, I'll tell you one thing, that what I just talked to you about, that would never, ever happen here at F&W. It's not possible. There's way too many tests that would be conducted on that motor. While it's being manufactured, that thing would have got red flagged way early on in the manufacturing process. And I'm not suggesting other pump companies, you know, would be more capable of doing that, perhaps. But here's where you're going to find it most of the time. You're going to find it in that underwater splice. That seems to be the most logical place where it could happen. And again, you know, sometimes these wires aren't nice, vibrantly colored like they are when they're brand new on the spool or the day they went in the well. These things come out of the well sometimes. Heck, you can't tell one color from the next. So check it there. Check it where that splice is at. That's probably where you're going to find that these mixed leads took place. And again, the indicator is going to be higher and lower values of resistance. All right. All right. So again, this is within range. We're always good. No mixed leads. But if you're coming in higher and lower, again, that's going to be an indication of mixed leads. The lead identification. Look, if you know that the lowest value is going to be yellow and black, and that the intermediate value is going to be yellow and red, and that the highest values, your red and black, your start and run windings together, if you know that, I'm telling you one thing, if all those leads were black, I don't care. I got 3 black leads and a green ground wire. Knowing what I just told you, you give me a multimeter and I'm going to sit down and do my test with a few minutes based on my results, based on the resistance values I'm getting. I'll just record those things. And when I'm done, I'll tell you which one should be the yellow, which one should be the black, and which one should be the red wire. All right? So it's easy to determine lead identification that way. All right, we're down to one of the last things we can check with a multimeter, and that's simply called a ground, okay? And the reason I wanted to pull this out from those other 4 is that the method that we're going to use to test a motor for a ground is we're going to take each lead to ground, all right? Each lead to ground. So let's do that. You know, on a 2-wire motor, you're going to go black A to ground and that black B to ground, all right? So you'll do that twice on a 2-wire motor. So let's just go ahead and see what happens here. If I'm getting no resistance, all right, that means I'm getting an infinity display in my multimeter. That's a good thing. And I want to make sure that I don't have any resistance across any of those wires going to ground. So I'm going to go red, black, and now yellow to ground. And if I'm getting no resistance, none, that motor is not grounded. So if you put a ohm meter on a colored lead and a green ground and you're getting no resistance, I'm telling you that motor is not grounded. I'm not telling you it's a good motor. I'm telling you it's not a grounded motor, right? So it wouldn't be a grounded motor. On the other hand, if you get any resistance whatsoever, any, that's an indication of a grounded motor. And so it's very, very fundamental test here to check a motor for a ground. You're either looking for resistance or not, okay? And that's going to determine whether the motor's grounded or not. I was doing a class one day and a contractor come up to me, I don't know if it was before or after the class, but what he said to me is he looked at me and said, "Hey, Mr. Painter," he said, I pulled a pump and motor out of a well earlier this week. Must have been a 3-wire motor, because he told me, he said, that rascal was grounded on all 3 legs. He said it was grounded on all 3 legs. In other words, I think he was trying to emphasize, man, this motor wasn't just grounded, it was really grounded, all right? Well, look, that's not uncommon, all right? What he was explaining to me was more the rule rather than the exception. So what I would say to you is that anytime you have resistance coming across a lead to ground, you're more than likely going to get resistance off of every one of those leads to ground. That's the commonality. That's the thing that's more likely to happen, right? You'll get so, you know, he got all excited about it, but that's not uncommon at all. I thought I'd outlive this, but apparently not. You know, these motors, these submersible motors, when they were first manufactured back in the day, the very first submersible pumps had motors on them, and those motors had no ground wires. There was no ground on those motors whatsoever. So it was up to you, the installer, to figure out how you were going to ground that water system or ground that motor, right? Those motors, believe it or not, there's some of them, they're still out there, and I don't know why you would ever want to check one and replace it, but if you wanted to test one of those old motors that didn't have a ground, you need to create one. And so if that motor was in the well, we talked about that in a previous question, if that motor happened to still be down in the well, and that well was a steel cased well, you can etch the side of that casing with your probe and get a nice ground, and you can take a reading that way. If the motor's out of the well, you can do the same thing on the side shell of the motor. You can etch the side shell of that, but you want to get a good ground, just like if you were trying to jump a car, right? You don't need to put the negative cable on the negative post. You can put it on a steel piece of the chassis. All right, so there you go. We got all these things that we can determine with a multimeter. And again, what makes this valuable is understanding what those resistance values are actually telling us. So that when we have a failure, we can at least know why or what caused that failure. So our takeaways in this first section, we're winding down here, but our takeaways in this very first section hopefully are just a couple. This here, all right, anytime we fall within a specified or a published range, and again, every pump manufacturer or motor manufacturer publishes this. We don't keep it a secret, we publish it. But when we're within range, that's good. If we come in lower, you all know what that means. It means you're short, all right? It means you're short. If you're coming in higher, then that's that window. We got an open winding. If we don't know for sure which way we're coming in both, that's mixed leads, all right? So there's some takeaways. And this little math equation, I'm telling you, this is a great, of all of them, this is probably the best one to hang on to. Because again, this is the same with everybody's motors manufactured. All right, I'm going to wind this down. I'm not sure where we're at here on time. We started at about 10 o'clock, and I was trying to keep these at about 40, 45 minutes, so we're doing all right. We're going to wind this up with a little discussion on Meggers or Megohmmeters, all right? That's a horse of a different color, to be honest with you. If I'm in a classroom and I ask by raise of hand, how many of you contractors possess or own a multimeter or an ohm meter, and I'm going to tell you, man, every hand's up in the air. And if I follow that up with the question about the same question is, how many of you possess, a Megohmmeter or a Megger? Oh boy. Not nearly as many contractors would have Megohmmeters in their possession as multimeters. But let's look at the difference between the two, all right? And maybe the reason that Meggers aren't quite as popular as maybe the multimeters is in our industry, we only have one use for them. And that use is up on the screen here. That's the only thing a Megohmmeter is going to do is it's going to determine what we call insulation resistance, all right? Insulation resistance. The big differences between a Megohmmeter and a multimeter, right? We talked about the multimeter. It measures resistance and it expresses it in ohms. A Megohmmeter, on the other hand, is going to express that resistance in what's called megohms. Let me give you maybe a comparison, all right? If you were to go into a medical facility and have an X-ray or a CT scan done, kind of like the ohm meter, right? It's going to give you a little more inside look, a little better inside look of what's going on inside your body, right? It's just like, kind of like the ohm meter is giving us an inside look. But that would be the X-ray and the CT scan. Now, there's another one. If you've ever had an MRI, now that's a horse of a totally different color, right? I mean, that is a whole lot more, that magnetic resonance imaging, that is a whole lot more detailed, just it goes deeper. Kind of like the Megohmmeter. Look at this. It takes 1,000,000 ohms to equal just 1 megohm. And again, a Megohmmeter is going to measure in megohms. So there's a big difference. Here's another one, and this is an important one. that multimeter, it's got a 9-volt battery in it. So what, right? I've got kids that used to put that daggone thing on their tongue, all right? No big deal, but you'd never want to do that with a Megohmmeter. That thing throws a lot of voltage, and it can throw more than that. 1,000 volts that I've got up there. So you want to be careful with that. That thing will get your attention in a hurry, all right? So that's a big difference between the two. But what a Megohmmeter is going to do is it's going to check the insulation of that pump cable to make sure that that insulation is all intact, all right? And it's going to determine, it's going to exploit any weaknesses in that pump cable. So if you've got you're replacing a pump, but not the cable, over time, that cable is going to degrade, right? It's going to degrade. You can get pits and cracks and all those things going on. Your multimeter probably ain't going to pick any of that up, but that Megohmmeter sure will. So again, it's going to check for that insulation resistance, and that's going to do that right on down into the windings of that motor, the copper windings in that motor. I get asked, hey, painter, this copper windings, is it just standard copper? No, it's not. This copper wire that is used in the electric motors is a magnetic copper wire that has a thin film of insulation over the top of it. It's kind of like a varnish or an enamel. It's heat absorbing. And we want to be very careful that we don't prematurely wear that insulation off. And so when we build these motors, we encapsulate all those windings in an encapsulation so they're not vibrating against one another. But over time, that insulation is going to degrade. And so, again, with a Megohmmeter, it's going to be able to determine the insulation resistance in not only your drop cable, but right on down through your splice into your motor lead into the copper windings in the bottom of that motor. All right. Good or bad? Here, this is an industry standard. These values are as an industry standard when using a Megohmmeter. When using a Megohmmeter, by the way, like testing for a ground with a multimeter, when using a Meggers, you're always going to go each lead to ground, and you're looking for resistance, right? Each lead to ground, and you're looking for resistance. And here's kind of your thresholds for that resistance. We talked about this in a question earlier. Are we testing this motor in the well or is it out of the well? Well, you're going to want to know that when you're testing it with a Megohmmeter because the published values are going to be different, all right? We also want to know not only is it in the well or is it out of the well, but I want to know is it a new motor or is it an old motor? Is it a used motor? Because once again, those values are going to change. Now, apparently this is not up for debate. This is a published value that is used by all pump motor manufacturers, and so here we go. With a new motor in the well, a brand new motor, you drop this pump and motor down in the well the very first time you put a Megohmmeter on that, you ought to get 2 megohms or more, all right, 2 megohms or more. If you conduct that same test with a used motor, that goes down to 0.5 megohm or more, all right? But that's a threshold for a motor that's in the well. And that's taking into account all that drop cable that we talked about earlier. Now, if this motor's out of the well, all right, these values are going to change. So a brand new motor coming right out of the box off the shelf, you put a Megohmmeter on it, that ought to be throwing 20 megs or more as a brand new motor. If it's a used motor, half that, 10 megs or more. All right, but these are industry standards, and the only reason that I want to bring these to attention, and these are also available in publications. It's going to be in that motor application guides that we talked about. But the reason that these thresholds are industry standards is this. If you come in lower than any of those, in the well, out of the well, new motor, used motor, if your resistance value on your Megohmmeter is coming in below any of those thresholds, well, then the recommendation is not to reinstall or install that pump and motor because it's either dead or it's dying or it's near death. So anyway, folks, those are the kind of the published publications there you might want to get your hands on. It's a motor application guide there on your right, and then the resistance values for Megohmmeter there on your left. If I look at the clock, we're at about 10:40, and I wanted to try to keep these down to about 40 minutes. Hey, when we look at, I got another question coming in.
Yep, they asked, will these lives be on the YouTube after you're done recording?
Okay, the question, will these lives be on the YouTube after we're done recording? As long as they put a bag over my head, I'm good. Anyway, hey, listen, we got motors of all, yes, the answer is yes. But motors of all horsepower, of all voltage, and of all phases, all right, single phase, three phase, they will all have similar resistance values. Unlike the multimeter that we use, and we saw those values change by horsepower, when you're using a Megohmmeter, that's not the case. They're going to be very, very similar in resistance value. And then this is a good final note, okay? If you're going to be testing that motor and it's not in the well and it's on a table, make sure it's a non-conductive surface so that you don't get any surprises. Hey, listen, yeah, I got any more questions coming in?
Yep, they said, Meggers can save so much time and headache with VFD applications. Do you agree?
Absolutely. I would say that, I would say it this way. If you're in the business of installing and selling variable frequency drives, I don't care whose brand it is, these things throw a lot of voltage, right? They can have voltage spikes. And I'll tell you, I don't know if I would want to be in that business without a Megohmmeter, because again, that cable that running from that drive out to that pump motor, that's very important, that it's sized properly and that it's in good shape. And a Megohmmeter is about the only tool that you'll have that will be able to answer that question for you. So a little long-winded answer there, but if there's no other questions, I do appreciate you joining me on this little morning broadcast, and we're going to do a bunch of these between now and the end of August. Again, try to get in on all three sessions of any given track. One track's kind of like for water systems, the other track's kind of like for irrigation. You guys out west, you do both. I know that, and so for you, you might want to catch all of them. But anyway, listen, I appreciate you, and glad to be with you today. And subscribe to our YouTube channel. That's where you're going to find these things live feed. That's all right. And also subscribe to our newsletter, I'm told. So again, have a great weekend, and I hope to talk to you soon. Thank you very much.